Let's solve Intro to NLP, or Natural Language Processing. This is actually our first problem on NLP, and this is going to be really exciting because now we can finally get into the application of neural networks. Our examples and our problems have been maybe a bit abstract so far, but we're finally ready to jump into NLP and build models that can do interesting things like generate text, detect emotion. We're going to build a sentiment analysis model in a later problem, and we're finally going to explore NLP in more detail. So in this problem, we're actually going to load in starting from a raw body of text, so just strings, and we're going to set up a training data set. You may have heard that ChatGPT uses like almost the entire internet for training, but that's just a giant string, right? You could actually represent that in one massive string. How do we actually convert these into numbers? How do we convert them into integers, these characters, that the model can actually understand? Because these models that obviously work with matrices and all these matrix multiplications, the model needs to take in numbers, not strings. So in this problem, we're going to do exactly that. We're going to do something called tokenization. Tokenization is just a fancy term for encoding whatever your input to the model is. In this case, it would be strings. How will you encode the input, and specifically, how will you break it up? Would you break up your sentence into words, into individual characters, and how will you encode each of those tokens once you've broken them up? How will you encode them into integers? That is the process of tokenization. And we're actually given two lists, one list of positive strings and one list of negative strings. So we can imagine that this sort of data processing that we're going to be doing in this problem is going to be used for a sentiment analysis model. And a sentiment analysis model is just an AI model that can detect emotion within text. And that's actually going to be the next problem we solve. I highly recommend you solve that problem after this one. And one thing I wanted to clarify is that this set of problems, the goal is not going to be parsing and processing data. Instead, we're going to focus on how these models actually work. But we do still need to do one or two problems on how we actually set up the data sets so we can feed them into the models for training and ultimately get those outputs that we want. And the problem is actually telling us that the lexicographically smallest first word should be represented as 1, the second should be 2, and so on. So that's how we're actually going to encode each word as an integer. That's the rule that we're going to use. And in the final tensor that we return, we should list the positive encodings before the negative encodings, and that's just because the positive input comes first, so we'll process them in that order. Let's just make sure we understand the example. The first sentence is Dogecoin to the moon. So we can imagine we might be feeding these examples into some sort of sentiment analysis model that is going to detect emotion in tweets. That's just one application of this kind of model. And then maybe this fuels some sort of stock trading algorithm after our model has detected the emotion in, say, Elon Musk's tweets. And based on that, we might buy or sell a certain stock. And we can see that Dogecoin is encoded as 1, 2 is encoded as 7, the is encoded as 6, moon is encoded as 4, and there's actually a padding token. The 0 will be used for padding, and that will actually be added to the end to ensure that our first row in this tensor can be the same length as the row for the second tensor, as we know there's actually one more word there. And this padding that we're doing, we don't actually have to implement that ourselves. There's actually a function in PyTorch that we can call. All it really needs to take in is our list of variable length tensors. So it should take in a normal Python list of PyTorch tensors that each have variable length. And this function will automatically pad them all to match whatever the longest tensor is in that list. So we will then end up with a rectangular non-jagged tensor. And I think the default padding value will be 1, and we should set batch first to be true when calling this function. And that's just so we actually end up with a tensor that is 2n by t, where t is the length of the longest sentence, n is the number of positive examples we have, and the number of negative examples we have, so we have 2n in total. If we don't set batch first to be true, the return tensor from that method will actually be t by 2n, which is a bit weird, so we just need to set batch first to be true. So our goal here should actually be to construct a mapping. Our goal should be to build a dictionary that maps every single unique string, every single unique word in our input dataset to some sort of integer. So we want to build some sort of dictionary that maps strings to integers. And how would we actually build that data set, build this dictionary, given that we know we have to sort the words in lexicographical order? Well, if I actually had a list, if I had a sorted list of every unique word, in our input data set, then this would be really easy, right? Because I could just iterate through this to construct the dictionary. And we know that the 0th index, we would actually add 1, since we know we want to reserve 0 for padding. And we're actually going to start our smallest word, our lexicographically smallest word at 1, the second at 2, and so on. So we could actually iterate through this sorted list. If I had a sorted list of all the unique words in my input, and I've sorted them based on lexicographic order, I could just iterate through this to construct this dictionary. The actual values in this list would be the keys in the dictionary, and then the index plus 1, since it would be obviously be using 0 indexing, would be the values. And then once I have this dictionary constructed, once I have this mapping to generate the final return data set that we want, I would just iterate through the entire list or the 2 lists that are given, and for every single word in each sentence, I would simply call the dictionary. I would simply query this dictionary to get the encoded integer for each string and append this to the appropriate list for that string, for the corresponding sentence. And then we call our pad. We call the pad function at the end to make sure we end up with a 2n by t tensor. So how do we actually build this dictionary? Well, earlier I said that if we had that list of all the unique words in our data set, so we've kind of removed all the repeated words, because remember, a given word could, in some arbitrary data set, some arbitrary list of strings that's given to us, it could appear more than once. So if I had a list of all the unique words and I sorted that list, then we would be good. Then we could construct the dictionary as I talked about earlier. So it's just going to come down to collecting all the unique words, eliminating repetitions in the input data set. And we know a data structure that could help us with that is a hash set, or just a set in Python. So if I actually go through the input list of strings and add every single word to a set, then I will actually have all the desired words that I need in this set, and then we can actually cast it. We can convert that set into a list, and then we can actually sort it, and then we have the sorted list we want. We can build the dictionary, and then we can call or query the dictionary for every word in the input and return our final desired list. So let's add all the words in our input of strings to a set. So we'll just call this our vocabulary. And we're going to actually have to split up each sentence, which is a string, into words, and then we can actually use .split for that to actually get words separated by spaces. So we can just go ahead and say for each sentence in positive, and then for each word in sentence.split, that will actually return a list of all the words in that string back to us. So we'll automatically break up that string based on spaces. We can just say vocabulary.add word. And we want to actually go ahead and do the exact same for the list of all of the negative emotioned sentences. So for each word in sentence.split, we would just say vocabulary.add of word. Then we can actually convert this set to a list and call sorted so that we get the sorted list that we talked about earlier. Now we want to build our word to end dictionary, which can easily be built by just iterating through the sorted list. So we can just say for I in range of len of sorted list, and now we just need to map every word to an integer. So word to int, well, the key should just be sorted list at I, whatever word is at that index. And the corresponding value should be I plus 1, since we want the smallest word to have value 1, the second smallest word to have value 2, and so on. Now let's encode every sentence as a tensor of integers. So this list is actually just going to be all the tensors. This list is going to have size 2 times n, where n is the length of positive as well as the length of negative, and every element in this list will be a tensor. And then we'll call our padding function to ensure all the tensors have the same length. And the way we're actually going to code this up is we're first going to convert every sentence to a list of integers, and then we'll just call torch.tensor to go ahead and convert each list into a tensor. Since tensors are not really something you can dynamically add values to as you can with lists in Python. So we'll go ahead and say for sentence in positive, we can go ahead and say for each word in sentence dot split, we just want to create a new list, right? So this is going to be our current list, and we're going to append to this list. So cur list dot append, and then we can go ahead and say word to int at word. So we're actually getting the integer conversion for that word and putting it into a list. And then once we're done with that, we can actually go ahead and append this to tensors. So tensors.append, and then we want to go ahead and convert the list to a tensor. So torch.tensor of cur list. And that's going to be the tensor that we want for that sentence. And then we just want to do the exact same for negative. Now we just need to pad our tensors, and that's exactly what we'll return. We'll return nn.utils.rnn.pad sequence, and all we have to do is pass in our list of tensors where those tensors don't necessarily have the same length. So that's in tensors, and let's say batch first equals true. And this function will automatically know to use 0 as the padding token. And we're done. And we can see that the code works. If this was helpful, feel free to let me know. And next, I would highly recommend jumping into the sentiment analysis problem. With all the problems you've done so far in this series, you're finally ready to code up an AI model that can detect emotion.